Hi, today I want to give a slightly longer demo. I've been posting videos of progress I've been making on implementing positional tracking for OpenHMD with the Oculus Rift CV1, and I've generally just been posting screen recordings without any kind of explanation of what is happening in them. So today I wanted to try and give a slightly longer explanation of the status of things and show some of the internals at work. So what I've got set up at the moment is a single Oculus Rift sensor attached to my PC and just the Rift headset for now, with the batteries taken out of the controllers so that they don't interfere with my demonstration until a bit later on. So what I do is I start the OpenHMD GL example, and if I just get that out of the way, then you can see there's a whole bunch of debug output being spat out. But also, importantly, if I move the headset forward, you can see I am moving in position, although it's a bit jittery. And I'll show you why it's a bit jittery by swapping over here and showing what I've got is a debug output that OpenHMD publishes using the Pipewire media transport engine that is gradually going to replace things like Jack and Pulse Audio, and is the avenue by which Linux will be doing screen capture over the next few years, and already is the avenue if you're doing screen recordings with Wayland. But anyway, what I'm using it for is to publish a video source that outputs some debug information. So when you have a Rift sensor attached and you run the OpenHMD tracking branch, my OpenHMD tracking branch, it will publish one of these video sources for each sensor that's attached, and it gives you the video feed plus some annotation about what's going on with the tracking. So in this case, what it's showing me on the right hand side is it's found various LEDs and it's colored them in red to say that it has labeled those as belonging to the HMD. And then if you look closely, you can see there's little blue crosses being drawn on the right hand side, and on the left hand side it's almost invisible, but and probably won't be visible in the recording, but there are tiny little red crosses being drawn over the top of each LED blob. And then finally there is this red square being drawn in the top left corner to tell me that it thinks that it has a lock on the tracking. So if I move the headset quickly, then that little square will disappear because it's not sure where the headset's gone, but then if I bring the headset back, it will quite quickly lock back in on that. And the blue crosses represent every time a frame is captured from the camera, what it's doing is taking the current pose of the headset as seen as it thinks it is, the prediction of where it's going to be based on the IMU interpolation of the orientation and position, and then drawing that into the frame. You can see it doesn't quite ever align, which is an interesting thing that I have yet to solve, but that basically points at a misalignment between the initial camera calibration or the actual calibration of the IMU that's provided by the headset's firmware. Ideally, what we should get for perfect tracking is that every time we capture a frame, we get those little blue crosses drawn exactly where the LEDs already are. And that it can then trivially just confirm, okay, we're locked onto the headset position. But you can see it tracks pretty well as I move the headset around, and it's drawing little grey crosses. It's doing a calculation about which LEDs it thinks should be visible and which ones are not, so it's drawing the ghost of the back LEDs where it thinks they are. So that stays pretty well locked onto the headset. which is good unless I move it too quickly, and then it slows down when it has to do a full search and match back up the LEDs again. So you can see if I cover up some LEDs, the video goes all chunky while it's, and the pose jumps around while it searches for LEDs to match up against again. So improving all of this tracking and filtering is the big to-do job still ahead, especially when I, for example, grab my right controller and slide the battery in so that it pops up. The controllers are much more challenging for the algorithm to match because there's fewer LEDs and they're frequently side on. So it has a hard time getting enough LEDs there to get a good lock. And also, for some reason, my right-hand controller, the IMU, really doesn't align well with the model. So there's some refinement there. You can see it's tilted with respect to what the controller actually thinks it should be. What the firmware in the controller tells me that the alignment should be, rather. So lots of filtering work to do. But anyway, I think I'm pretty happy with the progress that I've made there. So in last week, I've been on vacation from work, and I've had a few extra hours here and there to push the code forward. And one of the big things I've done is to improve this prediction between the pose that the camera sees and the tracking that the IMU is doing, and moving back and forth between world poses and camera view poses. It's made a big difference, I think. Still lots to do, but I'm pretty happy with that. So the big question, I guess, then is what happens if I plug in a second camera? And so the way that this is working is when I start the app each time, each sensor starts grabbing frames and looking for the devices and trying to match them up. So if I go and I restart this example, and now it has two sensors plugged in. So we'll see that it is now capturing, well, I'll look at the debug in a minute, but if I go here, I can see I've now got two debug outputs that I can look at. And as soon as it gets this first good lock, it's now taken that as its reference and used it to calculate the offset of the camera in the real world. If I bring the controller in, we should hopefully lock in on the controller. And meanwhile, in the other camera, if I bring this down and start the second camera running. It's on 75. So both cameras are now getting a view of the headset. They've calculated their positions in the real world and are translating back and forth between those views. And ideally we'd get it all locking in, but I think this is not quite ready for prime time yet. The two sensors thing, it's very dependent on the initial lock and calculation. The stage that you normally do when you're calibrating your room and the Oculus setup step gets a good look at your controller and calculates the position of the cameras in each room in the room, and then stores those in a calibration file. This is not doing that. It's doing it every time I start up OpenHMD for now. Eventually we'll have a calibration step and store that in a file as well. So I'll go back to one camera, I think, now, because one camera definitely works better than two for now. Although I'll just take a moment and I'll show you what happened in the log file with all of this very verbose logging that I've got turned on. So we can see it started by opening two cameras and then starting to capture frames. One of the other things that I've done in the last week is to take this frame capture and split it up into multiple threads. So there's one thread capturing frames from each camera and then passing them off to a separate thread per sensor for analysis. So sensor 0 gets a frame, starts looking at it, and when it gets the first good lock, it does this step. It says that it's calculating the pose of the sensor based on knowing where it found the headset relative to the camera, plus the orientation of the headset from its IMU and the gravity vector that it can detect, and then reversing that to say, right, I've seen it, I assume that's 0, 0, 0, your startup position for the room, and therefore the camera must be at this position relative to the headset with this orientation to the world, and now it's got a relative pose that it can use to convert back and forth between headset world position and what it expects to see in each frame. Okay, so the second thing that I wanted to show you today is SteamVR and what happens there. This has taken me a couple of attempts to get this to run because unfortunately it seems about half the time on this machine, at least when I run SteamVR, I get failures to start up the USB traffic and internal kernel errors allocating the buffers to do the USB transfers. That means my camera frames stop arriving and all of the positional tracking just sort of halts. But after a couple of attempts I've got that working, and that's kind of nice. So what I can do now is move the headset forwards, and you can see that after a bit of a delay it does that. Part of the delay is the fact that it's looking for the controller each time, and you can see the controller, hey there, the controller, and if I move that forward and I'm careful and lucky, then the controller does indeed eventually move around, but as you can see, the tracking's having a lot of trouble deciding where that controller is and which LEDs belong to the controller and which belong to the headset. But it's starting to work. That's the first time that I've had the controller doing anything sensibly. It points in the right direction, it gives me the laser, I can manage to click on things. I can't manage to play anything yet with this kind of jittery tracking, but everything is progress. I can bring up the menus, so controls are working. Yeah, I'm pretty pleased with how that's going, and there's still a lot of refinement and bug fixing, and most importantly the filtering that will allow it to cope with all of this jittering, improvements in the computer vision and optimizations for the performance. But I think it's progress. So thank you if you've stuck with the video this far. I hope that you're as encouraged by this progress and functionality in SteamVR as I am. I'm really keen to be able to do VR on Linux with my Oculus hardware, and I'd like to say thank you to the people that have been sponsoring me with GitHub sponsorships. And it really helps to know that there are people interested in seeing this continuing to progress. It helps me to make the time to work on it. If you're wondering where all the code is, it's in my GitHub branch of OpenHMD. In the Rift correspondence search, you can find it at this URL, which I'll put in the comments. And the code to use it in SteamVR is in Christoph's OpenHMD SteamVR repository, and I just yesterday merged back the controller support branch that we've been working on for a little while, so that functionality that I was just demonstrating in SteamVR should be what you get out of the box if you build SteamVR OpenHMD against my development branch. Thanks. I will see you all in the next video.